Hello students, welcome back to geometry. Today we're going to start chapter 9 for real. Chapter 9 is going to start off with the Pythagorean theorem. Now, hopefully this is something that you're familiar with. Pythagorean theorem is something that starts getting covered in elementary school, gets emphasized very heavily in middle school, and now we're going to cap it off with another lesson on it in high school geometry. So in case you don't remember, I'll give a short lesson on it. If I have a right triangle, the longest side of the right triangle is called the hypotenuse. And I never spell that right. I hope that's right. The other two sides are called legs. And what the Pythagoreans figured out is that if sides A and B are the legs and then C is the hypotenuse, then A squared plus B squared is always equal to C squared. So this is a nice, easy to remember formula that we can apply to this. So that means in this one I could call 5A and I could call B 12. They are interchangeable. I don't need to worry about keeping A and B straight. But C does need to be the longest side. So A squared plus B squared is equal to C squared. Or in this case, 5 squared plus 12 squared is equal to C squared. And now we can just solve. 5 squared is 25. Plus 12 squared is 144 is equal to C squared. 25 plus 144 is 169. And then in order to figure out what C is, I would just take the square root of both sides. So that would give me C is equal to 13. Now, what that means is that the length of the hypotenuse here would be 13, giving me a triangle with sides 5, 12, and 13. Now this is really nice because all three numbers are integers, and since all three of these numbers are integers, we would call 5, 12, 13 a Pythagorean triple. Anytime we do the Pythagorean theorem and we get three whole numbers, that is called a Pythagorean triple. So the more complicated version of this is, I didn't paste it here. 1 second. And we're back. Okay, like I was saying, the more complicated version of this is when the unknown is one of the legs instead of the hypotenuse. It's not terrible, but the calculation is a little bit more complex. But again, we would say A squared plus B squared is equal to C squared. In this case, I would say 7 squared plus X squared equals 14 squared. Or 49 plus X squared is, do you know your 14s? I'm gonna be honest with you guys, I don't know that one off the top of my head. Calculator, 196. So now I can subtract 49 from both sides. I'll get 196 minus 49 is equal to 147. And then I get x squared is equal to 147. I would then go and take the square root of both sides. And I would get x is equal to the square root of 147. 12.1243556529821. Now, this is an issue because this is an irrational number. Even though my calculator cut it off, it does actually go on forever. Now, in geometry, we want to answer with exact answers where it's appropriate. Since this is not a word problem and there's no context, I can't tell if a decimal or an irrational answer would be more appropriate. So I want to give the exact answer. So what I need to do is simplify the square root of 147. So if you remember how to do this, great. If you don't, I'll do a quick review. What I want to do is 147 is not a perfect square, so what I want to do is find any instances of perfect squares that are in there by factoring it. And I want to factor it until I get all the way down to the primes. So 147 ends in a 7, so obviously it's not divisible by 2, but is it divisible by 3? Let's see, 147 divided by 3. It is, 49. So that means in order to get 147, I would get 49 times 3. I know that 3 is a prime number. I can't break it down anymore. Now I can break down 49 into 7 times 7, and both of those are prime. So that means that the square root of 147 is the same thing as the square root of 3 times 7 times 7, or the square root of 3 times the square root of 7 squared. And the square root of 7 squared is 7. So I'm just going to move this over here. It would be 7 times the square root of 3. So I would say in this one, x is 7 square root of 3. Now, 7 square root of 3 is an irrational number. It is not an integer. So I would say that this is not a Pythagorean triple. Okay, now, moving into high school level, the converse of the Pythagorean theorem. Remember, converse means it's a theorem, but in reverse. So, the Pythagorean theorem says if it's a right triangle, then a squared plus b squared equals c squared. But now I can say if a squared plus b squared equals c squared, then it's a right triangle. So I would get this picture. It would be a 90-degree angle, A, B, and C. Now, this converse has two other pieces to it. If a squared plus b squared is equal to c squared, then it's a right triangle. But what if it doesn't equal? What if a squared plus b squared is less than c squared? And what if a squared plus b squared is greater than c squared? So I like to think of this in terms of the hypotenuse. So in the middle right here, we have c squared being equal to a squared plus b squared. In this one, the hypotenuse is bigger. So if you can picture this right triangle right here, if the hypotenuse gets bigger, you can see that it's going to stretch out that angle and it'll look more like this. So if the hypotenuse gets bigger, then that means then it's an obtuse triangle. And hopefully you can see where this one's going. If the hypotenuse were to shrink, so if a squared plus b squared is greater than c squared, this would look something like this. So in that case, then it's an acute triangle. Okay, so real quick, there's a theorem that we covered previously that I wanted to bring up because it's going to be important here. The triangle inequality theorem. And this has to do with what types of sides can actually make a triangle. So if I have any three sides, like 3, 4, and 5, can I make a triangle with them? Well, the way I like to think of that is if I take the 5 right here, and then I put a 3 here and a 4 here, will they be able to touch each other? So if I knock down this 3 and put it there, and then I knock down the 4 to put it there, will they be able to meet? So in this case, yes, they can. However, if I had 1, 1, and 10, if this is 10 here and it's got a 1 here and a 1 here, if I try to make them meet, that's not going to work. So if I had, let's say, a 5, no, not a 5. 7, a 3, and a 10. This would be 10 long, and then I would have 7 over here and 3 over here. And if I tried to push those down here so they would meet, 7 plus 3 is equal to 10. So those would fall all the way down, touch each other in the middle, and not form a triangle. They would make a straight line. However, if I made this one just a little bit bigger, like 7.1, now they would fall down and it would be really, really close. That's too big. It would be something like this. But it would be a triangle. So the rule is, in order to make a triangle, the sum of the two smaller sides must be greater than the third side. Okay, now let's put all of this together. Verify that the segments 4.3, 5.2, and 6.1 do form a triangle, and then is it acute, right, or obtuse? So first, is it a triangle? In order to figure this out, I'm going to add together the two smaller sides and see if that's bigger than the third. So 4.3 plus 5.2, not 52, 5.2, is equal to 9.5. 9.5 is bigger than 6.1, so yes, this is a triangle. Now, is it acute, right, or obtuse? Okay, so in that case, I need to do 4.3 squared plus 5.2 squared, and that is equal to 45.53, and then I want to do c squared, which is 6.1 squared, 37.21. So in this case, I get a squared plus b squared. Let's put that here. A squared, b squared, c squared. And in this case, a squared plus b squared is greater than c squared. So if I look at that, if a squared plus b squared is bigger than c squared, that means that the hypotenuse is shrinking a little bit. So it's not a right triangle. If the hypotenuse is shrinking, that means that I am getting an acute triangle.